Hi there. Today we're solving a coding problem in Haskell, which is a strongly and statically typed general-purpose functional programming language. The problem we're solving is the longest substring with at most k distinct characters problem. If you like this video, please give it a thumbs up and subscribe to the channel for more. Let's dive in. Here we have our problem description or instruction, which says to write a function that takes a string ss and an integer k and find the length of the longest substring t that contains at most k distinct characters. We have our constraint that k is at least 1, and we have a set of input examples and their corresponding outputs and an explanation of why their output is what it is. Let's begin by setting up the function signature for our problem. I'm calling this function maxSubstrLen. And it has the type of taking an integer, a string, and outputting an integer. Takes k, or string, and let's leave that there for now. Now, the string type in Haskell is a type alias for a list of characters, and that's what I'll leave here. Let's jump into the REPL to build up the body of our function. We are going to need some functions from the data.list module, which will come in handy. So let's import that. And we're also going to need a function from the data.function module a little later on. So let's import that as well. Let us also define an input string for us to use while building up the body of our function. And we'll take one from our example. ECEBA. There we go. One of the functions that from the data.list module that will be helpful in solving this problem is the tails function. If we call tails on our input string, then here we see we have some semblance of the substrings from our input string, but it's incomplete. And what we could do in order to get the full set of our substrings is to call the inits function on each of our tails. And there we have it. These are all our substrings, but it's not in the form that we would like. So we could flatten this list by using fold_r, where our constructor replacement is concatenation, and our empty constructor is our empty list. And there we have it. These are all our substrings. But this fold_r concatenation map recipe is really a predefined function called concat map. And there we have it, the same thing. And once we have this, we will want to filter this set down to the set of substrings that contain at most k distinct characters. So let's do that. We're going to need a function that takes a substring. I'm calling that ss prime. And we want to know that the length of the unique characters of SS prime is less than or equal to K, which we're using for 2 here. And there we have the substrings that meet that criteria. Once we have those substrings, the next step is to find the one that has the maximum length. And so we can use the maximum by function for that. And that maximum by function takes a function where we're going to compare on the length of each substring. The reason why we imported the data.function module before was to get access to this on function. And there we have it, the longest substring t that contains at most k distinct characters. And then we will want the length of that substring, and this will be the function body. So we can begin by finding tails of our input string and concat map the inits function over that. And of course, we need to import data.list, and we need to import data.function. And then we will need to filter. With SS prime, nub will grab us the unique items from each of those substrings. Then we want to take the length of that and then check that it's less than or equal to k. And once we have that, we will want to get the maximum by comparing on the length, and then we will take the length. There's a lot that could be done to improve the way this function is written, and we'll get to that in just a moment. Let us verify that this works. So if we load our file, it works. It loads, and then we can call our function with 2, and let's give it the second example. And there we have 3. Let's try this with our third example. And there we have 2. Now let's refactor this. So whenever we see that we have a function argument that is at the extent of the left-hand side and the right-hand side, it means that we could rewrite this as a point-free function. So we could get rid of that there from the edge of the right-hand side and get rid of the argument from the left-hand side. And then we could also substitute our dollar operator with function composition. Ooh, no highlight. Let's try that again. Substitute dollar with function composition. There we go. So that's what that looks like. Our filter function could also become a point-free function where we change this to be an infix, a prefix function. So if we did less than or equal to k, and did this, then we would see that this looks like it could be a point-free function because we have our argument to the extents of the right and the left-hand side of the function. So let's get rid of that. Let's get rid of that. And let's check that this still loads, and it does, and it still works. Wonderful. And that would be the solution to this problem. I will provide the link to the code in the description. If you liked this video, please give it a thumbs up and subscribe to the channel for more. Please let me know what you think of the solution in the comments and how you would go about solving it. Follow me on Twitter or Medium at Onel Harrison if you'd like to see my content on those channels. Until next time, peace.